Hello, everybody. Welcome to introducing the Lovabond ICX launch event. It's 4 p.m. in UK time, so we've got people joining us from all around the world and various different time zones. And we'll just wait a couple of minutes so that a few more attendees can join us today.
This is our second event of the day. We had very well attended in the early hours of this morning. More sort of people east of us, more for the west.
Okay, so we'll start off with some basic housekeeping. We're presenting today in Microsoft Teams. For those of you that are not familiar, there are some tabs at the top of the screen that you should see. And we have the chat functionality turned off on this, but you will have the opportunity to post any questions as we're going along in the Q&A tab there. And we'll address those questions towards the end of the presentation, but we welcome any questions as we're going along. If you just click on the Q&A tab, type your question through, and then towards the end of the slideshow, we'll be able to review those. The other thing is, if you want a better view of the presenters here today and the presentation, you can click on View and then click on Speaker View, and it gives you a better view on what's going on.
I'm not sure they want to see more of us, Matt, but
that's right. Okay, so we're at 2 minutes past the hour now. We've given some time for people to join us, and I think we're going to start the presentation. So for those of you who are not familiar with us, we've got Matt Russell joining, who's a product manager for the colour products here at Lovabond in the UK. And so Matt's been working for a very long time at the organisation. Myself, Matt Bowick, I'm the sales and marketing manager for the colour business. I've been here for about three and a half years now. And we're both of us here today to talk you through the Lovabond ICX colour spectrophotometer for platinum cobalt measurement. In today's session, we'll be covering off the following points in the next hour. So we'll be introducing the product itself. We'll be talking about the specific market and applications that are intended for the product. We'll be talking about why customers should buy the product. So that's based around the voice of the customer and the surveys that we did with our existing customers within the field. We're going to be taking a deeper dive into the product technical specification and performance specification on the ICX. We'll have a review of all the sales and marketing tools that we put together for the product itself. We'll be talking about the next steps and what will happen next in your market. And finally, as I mentioned, we're going to have the Q&A session where we can address any of your questions at the end of the presentation. So without further ado, I'll introduce the product itself. We would like to make you aware of the product in terms of the messaging and positioning, why we've conceived this product in the first place. We saw a need in the market to have an extremely accurate, repeatable and reliable piece of kit that would measure specifically platinum cobalt at AFA colour scales. We know from our research that platinum cobalt colour scale is the most widely used colour scale in the market for transmissible liquids, beyond that of, say, C-Lab. Even Lovabond RYBN, platinum cobalt, is the most popular used scale for colour measurement in liquids in the market. And we felt that there was a need for a more accurate version of the PFXi that we have been selling for the last 14 years. And this has been driven by some key trends within the industry and the market. And we position our product so that we like to say that it's precise in the fact that it's industry leading levels of accuracy and repeatability. We are the only company out there that's actually quoting and publishing our accuracy and repeatability values and performance for platinum cobalt on a color spectrophotometer. The users we know want an intuitive system that's really easy to get on with, easy to use, and has methods that are easy to follow so that they can get those reliable and repeatable results. And of course, the final thing that is a key part of the product and the way that we've conceived it and marketed it is that it's a reliable product and it's highly robust. We know that platinum and cobalt color scales outside of water testing applications tend to be used in highly sort of aggressive chemical environments with samples that are either aggressive, or even the use of platinum cobalt on the higher ranges that's aggressive and corrosive in its own right. So we know that the users want to have longevity of their products. So we're saying that our product is differentiated, different from other products on the market because it's precise in its inherent nature. It's very intuitive and easy to use, and that it's reliable and robust for long-term use in the lab. A little promotional video for you to get an idea of how the instrument looks. So you just saw an overview of the product there. If you remember anything from that, it's the messaging that the differentiator that we've got behind this product is that it's precise, intuitive, and reliable for our users. Okay, so the target market we classify as the industrial chemical sector, and there's many subsectors that will fall into that industrial chemicals sector that we're targeting. So platinum cobalt, as you know or may know, is very popular for its use in the water testing labs or environmental testing labs. But we're looking at users of platinum cobalt at the lower end of the platinum cobalt scale, where they're measuring chemicals for various different uses, whether it's agriculture, healthcare, pharmaceuticals, manufacturing, or specialty chemicals such as EV. That's very close to being colorless, so from pale yellow to colorless in its nature, and there's a trend for an increasing level of repeatability and accuracy at that low level of platinum and cobalt range. The industrial chemical sector itself is absolutely enormous, estimated to be over 6 trillion in 2026, and a lot of that is coming from Asia and China. The supply chain is integrated all over the world. So there's definitely a growth for requirements of use of platinum and cobalt color scales within the chemical industrial markets. The name Lovibond ICX was derived from the target market that we're going after, so the industrial chemical market, the ICX. Talked a little bit about the electric vehicle subsector there, and especially in China, Asia, and of course now all over the world, this is definitely a growing market sector and opportunity for us. We have first identified this in China, and the EV battery manufacturers' requirement for our PFXI existing in the labs to do a better job of being more repeatable, more accurate at low-level platinum cobalt. So the specific chemical that they're trying to measure the purity of is lithium hexafluorophosphate, LiPF6. That's a key ingredient into lithium-ion batteries, and it's the more colorless it is, or the lower the yellowness index is for that particular chemical, indicates its purity. And so we know that the internal SOPs within some of the key accounts in China are demanding very low, high levels of accuracy at low level platinum cobalt, below typically below levels of 10. And so they want that, repeatability of measurement to know that the raw material is good for their integration into their batteries, and it gives them a long-lasting battery. So we know that this is a growth area, and we've been driven to improve the specification on our existing product, the PFXI, and is really one of the reasons why we've developed the Lovibond ICX. But there are, of course, other wider applications out there. We're not just looking at the EV market, and arguably the bigger prize could be found in these other sort of subsectors that are based in the petrochemical industry, microelectronics, resins and plastics, chemicals manufacturing, whether it's for agriculture or mass consumption within pharmaceuticals. It's quite diverse. A lot of the companies that are involved in these particular sectors are blue chip international organizations. And so we do have relationships with many of the companies already. And of course, we do have installations with the PFXI within these particular market sectors. We did some analysis on the market size, and this is a little bit of an estimation, but we would like to refer to it as being a low range estimation. We expect the market for benchtop spectrophotometers measuring just platinum cobalt color scale to be around about $14.5 million annually across the world. You can see the split there, estimated by the top 10 countries, with others coming in as a blob at the end there. That's been derived from various different reports we don't know necessarily how accurate it is, but it could be some guidance to understand what the potential could be within your particular local territory. If you were to break that 45 million per year down into an average net selling price of $10,000, you might get estimated volumes of more than 4,000 units per year around the world. And again, you can see the split estimation by top 10 countries. A lot of that is coming, obviously, the US with a huge industrial base. Again, China, which is following very closely behind and conceivably catching up with a large chemical and manufacturing sector serving the world. Germany, of course, with its industrial sort of background. Again, Japan, India with chemical and pharmaceutical growth, UK, QC and pharma, South Korea, specifically around electronics and industrial labs. Again, a burgeoning EV market in South Korea. France, again, big industrial. Canada with petrochemicals, Italy, food, QC and industrial, and then we have the rest of the world. So as as I've mentioned, we're building on the legacy of the PFXi series that was put out there in 2014. So it's more than 12 years old now. We have a very large installation base. I believe we have something in the region of over 10,000 installs globally. That product's getting older and older now. It's an opportunity for us to go into the market and review that installation base and encourage users to replace some of these older pieces of kit that have been very reliable in the lab and robust and well respected. But it's a good opportunity for us to churn over those older units. Some of them, as you can see there, dating back all the way to 2016. It's time for replacement. If you think these units are at 10 years old or possibly even older, it'd be an opportunity to go to these older installations and try to swap them out with the new Lovibond ICX. And to help you do that, I'm going to hand over to Matt, who will talk more deeply about what the drivers were for customers and some specifics around the product itself.
Thank you very much, Matt. A key to good product development is getting information on the market, getting voice of customer. So I personally met a lot of our customers over the years when I was in a sales role, but also more recently as a product manager, going to their facilities, talking to them, understanding their requirements. We're of course involved with standard bodies like the ASTM, ASTS on the edible oil side. Also attend a lot of conferences, seminars, questionnaires, getting lots of information. So we wanted to understand, we realised there was an opportunity to be had with this industrial chemical market. And one of the key things was to understand what the customers wanted. So talking to our customers, probably accompanying some of you customers, we've got some useful feedback from them. They want a new modern design. You know, people like the PFXi. We still sell a lot of PFXis, but it's starting to look older. People want something fresher, newer. We get it. So we've got a new design. You go to any lab, often they don't have a lot of free benchtop space. They've got kit there, other instruments. So they want a small benchtop footprint, if possible. The PFXi is a good instrument, but it's quite long and it does take quite a bit of space up. Key thing, particularly when we're talking to the EV, the electrolyte manufacturers, is that they were telling us that the PFXi was not repeatable, reproducible and accurate enough. And it's really been the development in the last couple of years in that the demand on the purity of some of the chemicals means they might need more sensitivity in the instrument in terms of its performance. So we need to make a better instrument. We want to comply with the standards. You know, people follow the standards, they care about the standards, the ASTM, the ISO standards. Want to handle lower volumes. We want to, particularly with the electrolyte chemicals, they're really aggressive. The lithium hexafluorophosphate is horrible stuff. You know, it'll burn you to your bone if you spill it on you. It's just horrible. It's handled in really very, very carefully. And you can see, I'll show you some of the damage it does to our instruments. Linked to that is that you want a sample chamber and you want an instrument that's chemically resistant. Also, you want something that can be easily cleaned and maintained. Obviously, we've got all those PFXis out there. We don't want to give an instrument that isn't compatible with the previous installations. You could have people want to use its interface. It must be simple and user friendly. Feedback from our customers, they like the PFXi because it is straightforward to use. But saying that, people want documentation, manuals in their local language, for example, Chinese, but also Portuguese, Spanish, etc. The main world languages. Want to see the previous measurement. We should be able to save and print results. Should be able to perform a diagnostic check to support you. Those of you that are dealers who are selling instruments, servicing them, you want to be able to do some technically supporting them. If you've got some functionality on there that allows you to do some initial tests to establish if there's a problem with the instrument or there's some other issue going on, that will save you, the customer, everybody a load of time. And you want to be able to check the accuracy of the instrument. You need reference materials, good reference materials. So let's look at the instrument first. As I said, It's approximately 30 centimeters square. Has a low profile. It's deliberately angled so that people don't put their samples on the top of them and knock them over into the instrument. Here next to a PFXi 880, you can see it significantly takes up, as we said, a smaller benchtop space. On the outside of the unit, you've got a control and display. It's not a touch screen, that's a deliberate choice. Often if the instrument's in a fume cupboard, you're handling with gloves and other equipment, you don't want a touch screen. A lid to cover the sample chamber, so you're not getting ambient light and protecting everything. Power button, measurement optimization LED, you see a little icon there. We have an LED that basically, if you have a tungsten lamp, that lamp can heat up and can cause some variation in readings. If you repeatedly take readings, you could either lock out somebody to make a reading or give them an indication of when it's optimum. What is the optimum pause between taking readings, which is 60 seconds. And a good solid heavy construction. And the instrument is made of aluminium, so very robust, physically strong and light. So cheaper to ship. Inside, we take the lid off. We can see here, if I take our little laser pointer, we've got optical system here with the lamp, fiber optic cable that takes the lamp through to where we have a reference detector. So the instrument is checking itself, every reading that is functioning correctly, and a spectrometer and spectrophotometer at the back. And our light path is based through the lamp, through these lenses, through the fiber optic, and into the spectrophotometer. And in terms of the lenses, we're making sure you're not getting the fiber optic, make sure we don't get a hot spot because of the filament of the lamp, so we get a nice sort of uniform light beam going through the sample. My little spot. It is a true spectrophotometer. It's not like a PFXi, either 9 filters or 16 filters. It's a true spectrophotometer measuring every 2 nanometers. That means we're taking multiple readings for every time the unit is taking a reading. It's flashing multiple times across the whole spectrum, visible spectrum, giving us a huge amount of data, averaging out, smoothing curves, means we have a really stable platform. We deliberately are not reporting spectral data. It is a color instrument focused for the platinum cobalt. Now, I talk about repeatability. It's always good to have definitions because my experience is there's often a bit of confusion with customers and sometimes between other people regarding what these terms mean. So if you go to the ASTM E284, there is a definition where repeatability is the closeness of agreement of repeat measurements on a single test sample on one instrument in one laboratory by one operator in a short period of time. So that's often going to be your smallest number. So that is you taking your ICX, putting a liquid sample in it, hitting the read button, waiting 60 seconds, pressing the read button. You're doing that's your repeatability of the instrument. So it's just going to be a smallest number you get. Then reproducibility is the closeness of agreement between the results of successive measurements of the same test sample, but changing conditions such as laboratory, operator, measuring instrument or time. So this could be the same instrument, but different operators using different cells, doing something different on a different day, different temperature, maybe measurement in the morning, measurement in the evening or the afternoon, and you re-zero the unit on a baseline measurement. That may you be getting to the realms of reproducibility. Also, if you have multiple instruments at different sites being used in the same conditions, you're getting to the realms of reproducibility. Then you get onto the accuracy, which is typically the number people get concerned about, which is the closest of agreement between a test result and an accepted reference value. So this is when you're in the realm of conformance filters, liquid references. I've got a standard, I'm putting it in my instrument, I'm getting a number. What is the value? What is the range of values I can expect to know which is good and what is bad? And we'll talk about liquid references, etc. later on. Now, as Matt alluded to earlier before, if you look at our competitors, they're not publishing this information. We have spent a great deal of time and effort to make sure we had realistic repeatability, reproducibility, and accuracy numbers, but also ones we knew we can achieve consistently. And when you get down to very low platinum cobalt, for example, 5, it's actually very challenging to get a good repeatable result and a good accurate result. And the accuracy figure actually depends on the quality of the reference materials you're using as well, because you have a variation in your reference material that could introduce a problem with your accuracy. There's nothing to do with the instrument. It's to do with the tolerancing and the variance in a reference material or a glass standard or the purified water used to baseline the instrument. So there's multiple elements into calculating things like accuracy, which if you control, you can get a low number. But in terms of platinum cobalt, if you were to get a platinum cobalt 30 and hold it up against purified water, you'd visually barely be able to see that. And so when you're getting down to these really low levels, to achieve this level of repeatability, reproducibility, and accuracy is challenging. But we've achieved it. And at a level that our customers have told us they want to achieve. Because particularly with electrolytes, if you've got a low platinum cobalt value, that can impact the final value at somebody like BYD or Tesla, where their final QC check might be a slightly higher platinum cobalt value, and that's an indication maybe some impurities in the sample. So everybody's trying to get as low a value as possible to make sure their product is as pure chemically as possible, in simple terms. Here's a full technical specification. I'm not going to go through the whole thing. It's in all the literature, it's in all the information. But as you see, we are clearly stating our accuracy, repeatability, and reproducibility numbers. Now, a key set of information is understanding the standards related to this. Platinum cobalt is also known as AFA and Hazen. And some customers will refer to Hazen, some will refer to AFA, some to platinum cobalt, sometimes depending on the industry, often just depending on, you know, the local sort of quality control manager, whatever standard, whatever they're used to referring to the standard as. But a key thing to note is ASTM D120905, which often comes up in conversation, is the standard test method for color of clear liquids, but it's a visual method. So people are often asked, I want to use an automatic instrument, but does it comply with 1209? Well, technically not directly, because you can't measure a visual method using an automatic instrument. But what you can do is measure ASTM D5386, which is a standard test method for color of liquids using triluminescence colorimetry, which is linked to D1209. So we refer to D1209 in our literature and say we're compliant with it. We're compliant with D5386, which is the automatic method, but that links to the vision method. But you should be aware of that. I know it's a little detail, but you know, if you want to understand it, it's much clearer. Then we have the ISO. Obviously, ASTM is American Society of Testing Materials. At a higher level to ASTM is ISO, which is International Standards Organization, which is basically consists of all the other standard bodies around. The various international standard bodies go to this. So it's a high level, the highest level standard. And you have ISO 6271, which is for clear liquids, estimation of color by the platinum cobalt color scale. I'm pleased to report the ICX complies with these standards. There's a little image there of 100 and a 500 platinum cobalt. So a little bit of a deep dive. Forgive me for going in a little bit of detail here, but hopefully you'll find it useful. ASTM D5386. We zero our unit or baseline our unit using purified water. And that's really important because that reading is the linchpin over which all your other readings are based around. If you have a bad baseline, you'll get bad readings. And it's important to note that in ASTM D5386, it states that the water that should be used should be type 1 or type 2 specified by ASTM D1193. So type 1 is of the highest purity. There's 4 grades of water in that D1193, of which type 4 is of the lowest purity. And I'll just show you quickly explain differences there from them in a second. And it should be noted that ASTM D5386 advises you take 3 readings and average them, and it also states you should round up to the whole number. You can actually achieve much greater accuracy now than a whole number, so perhaps we'll be having a conversation with the ASTM to see if there's something we can do to improve the standard by making it more accurate. So just talking about purified reagent water, I emphasize this because it's so critical. It's the first step that can go wrong is if you're not using the right type of water to baseline the unit in a cell, good cell, it will affect your accuracy, your repeatability, and your reproducibility of your instrument. So type 1 is ultra pure water used for sensitive procedures like spectrophotometry, atomic absorption, gas chromatography, and trace analysis. We now have in our facility the ability to make type 1 water. It's what we've used throughout all our testing and manufacturing. It's not to be confused with often what you see in labs, and probably when I was back in the dim and distant past, a chemistry student in the lab, you had the type 4 water, probably wasn't even type 4 then, which is the old deionized water which you use to clean glassware, wash your glassware. That is not type 1 water. And if you put, if you would not get a 0, platinum cobalt 0 in an instrument using type 4 or even type 3. So I cannot emphasize enough that good water should be used for the baseline measurement. Funnily enough, we actually supply that if you wish to buy some. 17 ISO 6271. This is where the term platinum cobalt color is used within the standard over the terms Hazen or AFA. So we made the decision, we didn't want to confuse people by using platinum cobalt here, AFA here, Hazen here. Throughout our documentation, we refer to platinum cobalt. This ISO standard also emphasizes your samples should be pure, no haziness, no particulates, no bubbles, and they should be removed. If they can't be removed, you can't measure platinum cobalt accurately. As Matt spoke about, sometimes people, as well as platinum cobalt, are interested in the yellowness index in parallel to platinum cobalt. So the instrument can measure yellowness according to E313. And a good old C-Lab, sort of Swiss Army knife, or a very multi-purpose tool for measuring colour. That is on the instrument as standard with standard illuminates and observers. And also this allows us to use things like glass conformance filters, because we can manufacture C-Lab glass conformance filters very easily, which we can use as a glass conformance reference, which I'll talk to in a bit more detail later on. So nice display. You can easily select by scrolling up and down the scale you want to be testing. When you're displaying the information, you've got options in terms of decimal places, 2, 1, or 0. And it's interesting, often if you set the units to, obviously, if you're testing repeatability on, say, a platinum cobalt 5, and you're 1 decimal place, you're going to get 10.2. Well, it depends what the nominal value of the reference material is, but you're going to get that variation in the number of 0.2. But if you've got set to a whole number, you'll just get 10, 10, 10 all the time. And it's interesting how many customers perceive that as being a 10 being more accurate than a 10.2. Just a point to note. Competition. If you take our most common competitor for this platinum cobalt scale, the HAK Leica 620s, even though not seen many of them in environments with electrolytes because they'll just eat the instruments, but that's another story. You'll note that because of our higher resolution, our 1 and our 2 decimal places, we can make more accurate statements about our repeatability, reproducibility, and accuracy. If you look at the 620 and the 690, the 620 will only report 0 decimal places. So the best repeatability you can ever get on a 620 is 1, plus or minus 1, because of the simple way they're reporting. Again, on the 690, on the Hazen scale, 0 decimal places. On the 690, on the AFA scale, which is both, all of these are platinum cobalt, you up to 10, well, up to 9, 0.9.9 is 1 decimal place. After that, they've jumped it to whole numbers. So you can see straight out of the box, the ICX is able to report more accurately and prove more accurately the sample chamber. This is particularly with a lot of industrial chemicals really critical. You need to have a sealed, you've got a lot of sensitive optics, electronics. You don't want corrosive chemicals or vapor getting inside the unit and eating the unit, because it's going to impact the, particularly when you want a really sensitive instrument, it's going to impact the accuracy. And we've, over the years, we've seen many PFXIs. I'm sure many of you have seen PFXIs covered in goop, full of oil, full of chemicals, where the product has been badly handled, been badly used. This won't happen with the ICX. You've got a double steel bulkhead, so you've got bulkhead and then a secondary sample chamber slots in and out, making sure everything is sealed. The lenses are sealed. There'll be neoprene seals around the whole thing, making it absolutely, you know, as tight as we can make it in terms of a sealed sample chamber. Then we have our, where you position your cell. You've got cell positioning guidelines, because like the base, a good measurement is based on a good repeatable process. So you've got guidelines indicating where you position your cell. So it's straightforward to any user. They visually can see where they should put their cell in the sample chamber. You've got cell positioning guidelines, and our instrument ships with a quick help guide which shows you where the optimum position for your cell to get consistency. You know, you don't want a new operator in a different shift putting the cell in a different position in the sample chamber, or not putting it straight and getting false readings because they are because of the positioning of their cell. Just a little indication of an actual photo of an instrument, of a cell there, with our PTFE sample cover on top of the cell to protect the instrument and the user. You also know in the sample chamber is you've got that little groove which allows you to use our W600 cells and our sort of narrower 10mm, the standard sort of 10mm spectrophotometry cells will fit in there because of that little dip. Now these are some real world images of PFXIs still functioning. They're real the tough old instruments, but where these are battery electrolytes, horrible stuff, have got in and it corroded and eaten away at the instrument. We even have customers making their own sort of improvised chemical resistant chambers using like wax paper and other parts. So we saw these in the market and thought, you know, we need to provide our customers with a PTFE sample chamber, Teflon. Exceptional chemical resistance, non-reactive, it's easy to clean, non-stick, and good thermal stability, and very durable in harsh environments. And to support that, you've got a PTFE lid that sits on top of our W600 cells to, you know, it will not fully make the thing airtight, but it certainly stops any vapors or other materials and gives you further protection of the instrument. We've actually modified that design now to be slightly deeper, so it sits more tightly in the cell, more securely. So we had some issues with people moving the cell around, and it sort of wasn't quite deep enough. That's been improved. So the display, we've got nice clear display, very simple. You've got on-off soft key, power LED, functional soft keys, LCD display, and that measurement optimizing LED. So when you take a reading, give it 60 seconds, let the instrument sort of settle, and then proceed with your next measurement. Display information, you've got your platinum cobalt or other information on the screen. You've got your various functions, you've got your path length, and then you've got your illuminate, your observer for C-Lab calculations. It's a full color display, multiple language options, as is the support materials. You have a prompt mode, so if you have a new user, maybe somebody new in the lab, you can set prompt mode on, makes it easier for them to use the equipment. You can view sometimes if you're checking, well, I'm checking, I want to check my repeatability. What was my previous reading measurement? I didn't write it down. Click on that. You can see your previous reading. You can save data onto the instrument and print data if you have a little thermal printer attached to it. You have an instrument diagnostic, which we spoke about. As a customer want to be able to check the instrument yourself. That would do, for example, checking the voltage levels at various points within the instrument, so you can determine if there's some sort of electrical fault in the unit. They can check the keypad is functioning correctly, testing the various buttons, checking all the functionality. And that's all obviously the manual details exactly what each of these functions is doing. You've got an easy removable lamp. My experience with spectrophotometers in sales was, can I change the lamp? Of course you can. Some manufacturers, you have to go back to the service center. Easy to change. You've got multiple path lengths. We standardize on the 100mm, but some customers might wish to measure, for example, C-Lab or yellowness at a different path length. That can be done. This is for reporting purposes only. There's no calculation done to compensate for different path lengths. In terms of what you get from the box, you've got everything you need to start using the instrument from day one. You get the instrument, sample chamber, power supply, power leads, memory stick with a manual in it, all the certificates you need, conformance filter, borosilicate cell. We chose borosilicate, but it's a bit more robust than the optical glass. But you could use an optical glass cell if you wished, or W100s. We ship these all over the world. We're an international company. A key part of our offering to people is that the instrument you buy will arrive in one piece. Quite a lot of time and effort went into new packaging for the unit. And as part of that, we did a whole load of shipment simulations. So we gave 3 instruments to an external company that does this sort of testing, put the unit in atmospheric conditioning, vibration testing, simulating the goods being in an aircraft, being trucked around, banged around in the boot of your car or the trunk. We were joking earlier on, I used the phrase pothole. I don't know if we should do a poll. People know what potholes are. Potholes are basically holes in the tarmac. I don't know if there's local words for it, but I like the word. Good British word. Pothole. Anyway, I digress. Vibration testing. We did drop tests because people chuck stuff around, drop stuff, and you can see some of the package here got dinged a bit. But the good news is, once we got the units back, we took them out, and they all worked fine. We did some post-test examinations. We identified a couple of issues, which, although they didn't affect the performance of the instrument, could be something we could improve. So we have improved that from that testing. We talk about purified water. We talk about sample positioning. We talk about an accurate instrument. You need to have good quality cells. These cells need to be clean. They need to be handled correctly and filled correctly. So again, there's a quick start guide that comes with the ICX. It shows, it should be 2/3 full. Don't fill it too little. Don't fill it too much. Don't have thumbprints on it. Don't have bubbles or particulates or dirt on the cell. All of that will make your instrument less accurate. Now, it's less of an issue in the Americas, but we do see this in some parts of the world where people think, well, your cells, we think they're a bit expensive, we're going to buy some local dodgy copies of our W600 cells, which is all well and good until you actually discover that some of them are not, the cell windows are not parallel with each other. In that diagram, you can see if you've not got parallel windows, that beam is going to refract it a little and might not hit dead center onto the spectrophotometer. And I've seen it practically at a customer. This is a customer we went to, was complaining about a PFXI not being accurate for platinum cobalt. We got out their cell and we examined it. It wasn't one of our cells, there's no Lovey Bond on it. And you can see, you probably see with your eyes that it's a bit wonky, it's not quite parallel. So we took a sample, his sample, we measured it in his local cell, then we took a Lovey Bond cell, we measured it, and guess what? The Lovey Bond cell measured perfectly. It wasn't the instrument, it was the cell introducing an error into his reading. Now, how do you now then check the accuracy of your instrument? You need to use standards and references. For that, we have glass conformance filters, and liquid references. Now, how do you use a liquid reference? We could sell a 500 ml bottle with a known value of 5, 10, 15, etc. You check your cell is undamaged. You check your cell is clean and free of contamination. Fit it correctly. Handle it correctly. Put it correctly in the instrument. Use the correct path length. Make sure the correct liquid reference is being used. If measuring a 5, use a 5. Liquids have reached temporary equilibrium. Some of these platinum cobalt reference standards are actually quite sensitive to temperature. So if the certificate says test at 21 degrees and your lab is at 30 degrees, you might actually get a bit of variance simply because of the temperature of the lab. So it's something to bear in mind. And we're going to be releasing a white paper detailing some of our findings about that. Obviously no bubbles or particulates, and make sure you're not using an old reference standard, you're not cross-contaminated it with another, or generally done bad things to it. Now, the beauty of using a liquid reference is the process I've described to you is the same process you'd use to test a sample. So liquid references are excellent in that they allow a customer to check their instrument under typical operating conditions. The only issue is they have a limited shelf life and you have a limited volume of the product, because once you pour it out of the bottle, it should be thrown away and disposed of. This is why glass conformance filters come in. We have a piece of glass in a filter with a known value. Obviously, if you're using it, you check the filter's undamaged, check it's not loose, it's not rattling around in there, it's clean, there's no fingerprints on it, it's correctly positioned in the instrument. And our manual details where you should position the filter, which is towards the back of the ICX. The correct filters being used. And the beauty of glass conformance filters is it's a direct verification of instrument performance. It's independent of typical operating conditions, as you're not using a liquid or a cell. So this is why all ICX ship with a conformance filter. Because the moment if you have a dispute or a concern about the accuracy of the instrument, you can position your glass conformance filter in it and do a direct check. Of course, for audit and checking purposes against scales like platinum cobalt, you should also be using liquid references. And we have platinum cobalt 0 for baselining and testing, as well as various other liquid references made to a very high standard for the ICX. But back to conformance filters, the beauty of them is they have no defined shelf life. Why can we issue conformance filters and liquid references? Because we're ISO 17025 certified. We've got the paperwork to prove it. If you Google UCAS and put 0630, you'll find our certification issued by the MPL off the top of my head. which also covers things like ASTM Gardener as well. So just to summarize, hopefully I've shown to you that we've got a new modern design. It's smaller than the PFXi. It's much better in terms of repeatability, reproducibility, accuracy. I'm not saying the PFXi is bad. The PFXi is suitable for certain requirements, and some people are very happy with, but other people are more discerning and they are getting more pressure on them to produce lighter coloured, less colourless liquids. So basically, we need a more accurate, to measure a lack of colour, we need a more accurate instrument. We need compliance with the standards. We need to understand the standards. We need to deal with lower sample volumes. We need to have a sample chamber resistant to chemicals. We need to protect the instrument from chemical spills. It's got to be able to clean it inside and out. Got to have an upgrade path from the install base we've already got. Got to have a nice, simple user interface. Local languages. You want to see what you've measured previously. Save and print results. And users want to do diagnostics checks, as do our technical and service team, so we can manage any technical support issues going forward more easily. And you want to be able to, if you've got an instrument, you've got to check, is it actually measuring? How do I know it's right? You've got to have reference materials in order to check it. I think that is me done. So over to you, Mr. Boak. I'll let you take over.
Thanks very much, Matt.
No problem.
Okay, so we've been through the product specifications, some of the technical detail there set out by Matt, and we've also summarised that in some of our sales and marketing tools that are available to you now. At the same time, we're going to be launching our new partner portal for the colour website, for loverbond.com website. If you have a chance in the coming days, we'll be sending out an email asking you to register for our colour partner portal, where you can pick up the launch pack for the ICX, and in future other launches that we undertake, you'll be able to pick them up from this partner portal on our website. So a few months back, we went out to you in the sales channel to ask you what kind of tools and resources you might need for launch of a new product, and we had a great deal of responses that came back, some really interesting things that came about, and we've tried to take that wish list into account and deliver what you'd asked for. So this is not an exhaustive list, but some of the things that were asked for were obviously the high resolution images for use on your websites or for your marketing campaigns. They're not just on the product, but we also got in action shots in the lab as well, be able to pick those up. We have 2 brochures, one for the EV market we discussed specifically, talks about applications in EV and the product use in that particular type of lab, and then a more general industrial catalogue or brochure that could be used for more wider applications outside the EV market. You asked us for more videos, and that seems to be a real trend. The fact that we've put together a set of videos. We've actually got 4 videos. You've seen the launch video that we shared earlier on, but we also have a method video, which is intended to show customers good laboratory practice and how to carry out the method according to the standard. There's another video that shows you how to perform a verification using liquid reference standards. And then there was a popular request for unboxing videos, which seems to be a bit of a trend. People like to see what they're buying and what's in the box. Again, we've got an application note that really goes into the data behind achieving the accuracy and repeatability values that we're able to quote on the product. We put together a sales playbook with some competition information in there and how to sell the unique advantages of our product over that of the current offerings in the market. I mentioned the Good Laboratory Practice Guide. Again, it's just it's a cheat sheet as to how to follow the perfect method when you're undertaking the sample measurement. There's a document on Lovabond cells and the importance of using quality cells. End user PowerPoint presentation. We've got examples of the certificates, and of course the user manuals and quick start guides. So there will be other things to add to that list. We are working on case studies and testimonials as and when we get the instruments out into the field. So to go on to the part codes and pricing there's a summary of all of the new part codes that will feature on the 2026 price list. The price that we're setting, the list price on the product, is around £8,500. And there you can see the associated accessories, the PTFE sample holder specifically, the cells. We've come up with the new cell packs, pack of 5 cells and pack of 10, which makes more sense if users are getting through quite a lot of cells. And as we refer to those special premium high quality liquid reference standards according to ISO 17025, we've put a lot of work into putting together these liquid reference standards, and the quoted tolerances for those liquid reference standards are far higher than our previous liquid reference standards, and better than that of any in the market. And what we said, and Matt alluded to it earlier, is that if you want a true verification on the instrument, then you should be using our liquid reference standards, because we have a low tolerance value on them, and so that it fits with the accuracies that are quoted on the ICX. We've put together a pack for those as well, which is a standard set, which comprises all of the liquid reference standards 5, 10, 15, and plus a litre of the Platinum Cobalt Zero, which is that ultra pure ASTM Type 1 water that we talked about earlier on. So we position the price so that it fit in with our existing portfolio. We're not getting rid of the PFXi 195. It's existing. Users that don't need that critical level of accuracy and precision can still have the PFXi 195. It's positioned a bit lower on the price scale there, and of course it has, in terms of its performance specification, it's lower than that of the PFXi 995 and the ICX. So we felt that the ICX could fit in between the 195 and the 995 in terms of its price positioning, and also of course benchmarked against competition out there. So what are the next steps for us? Well, your area sales manager will be in contact with you as our sales channel to discuss launch plans for the market next year in 2026. You have the opportunity to tell us what you might need for launch, in addition to all the sales tools that we've provided. As I mentioned, a link will go out to you in the coming days, inviting you to our partner portal on our website to download the launch pack, and you'll have access to all of the information we presented today and all the sales tools that we spoke about. Then I would urge you to follow us on LinkedIn. We're conducting a launch campaign, and we're actually next week having a Select Science, which is a media outlet for scientists to attend an end user presentation that looks at Platinum Cobalt troubleshooting and best practice, where we'll be announcing the launch of the ICX at the end of that seminar. So please share that registration, Select Science. We have sent some emails out to you in the channel there, just to make sure that you're sharing that with your database, your customer database and marketing channels, to get as much interest as possible with end users to attend that event, to give us some momentum and hopefully generate some leads for some sales going into next year. So to help things along, we'll also have an offer for demo units for you. We've come up with the concept of putting together a demo pack, which would comprise a 50% discounted Lovabond ICX instrument, put into a Peli case, which is a hard and protective case that will be able to be fitting into the overhead on an aircraft, so you can take it to the customer and to demonstrate with a pack of the verification liquid reference standards the performance that we're quoting on the instrument itself. So it's a very powerful tool to use in front of the customer. That you don't necessarily have to rely on the brochure or, word of mouth to sell the product. Use the offer of having this demo instrument to actually show the customer for themselves the instrument in action, and hopefully that will convince them and convert them.
And
So
Matt and I have,
yeah,
sorry,
go on.
I was going to say, Matt and I have carried those Pele cases around ourselves, so we've proven
Yeah.
didn't have any problems with customs. Although I wouldn't put the liquid references in your hand luggage, but the Pele case is it's a fantastic way to transport an instrument.
And showing the customer,
you can pretend you're in some sort of action movie when you click it open at the customer.
Exactly. Okay, so we've reached the end of the presentation. We haven't left very long, actually. We've overrun a little bit for the Q&A session. But as I mentioned at the start of this call, if you want to ask any questions, if you go to the Q&A tab at the top of the Teams portal here, Microsoft Teams portal, you can put in a question, and then we will review it and publish it. Looks like we have some questions on there already.
We do. Matt. Are you going to read them out and I'll answer?
Now I can read some out here. So we have one here from Monique. So Hack Lyco is the only competition? Question mark.
If only that was true. There's always competition. This purpose of this seminar isn't to be we're talking about our products. I'm not going to go and demolish and attack all the various other competitors. But I think we deliberately focus on the robustness of our instrument. There's nothing else on the market that's comparable with the ICX in those terms in some of these markets. And if you look at some of the Hack instruments, if you look at the sample chamber and the optics are, the optics are exposed, they're not going to survive they're water instruments. I don't mean that disparagingly, not designed to measure some of these chemicals. And in terms of pricing, I'm not going to list, there are other spectrophotometer manufacturers out there who measure platinum cobalt, but there's various pros and cons in terms of price, capabilities, etc., etc.
Okay. We've got another question here. I'll take this one. It was mentioned the estimated market share for the instruments measuring platinum cobalt is in the region of 4,000 instruments. Yeah, I based that on an estimated market value of around about 45 million USD globally for all countries, and then estimated an average selling price of around about $10,000. So we can say about 4,500 instruments globally. That's just an estimate. Some instruments sell for more out there, and some for less. So the question then goes on to ask, what instruments, spectrophotometers are they if they're not buying the Lovibond instruments? Well, we do sell an awful lot of PFXi 1951s into the market. By that measurement, we probably haven't got the greatest market share. Lovibond is very well known for its proprietary color scale, Lovibond RYBN, but we really want to be seen as the leader when it comes to platinum cobalt measurement. And now we're hopefully demonstrating that with the accuracy, precision on this new instrument, and the fact that it's really robust. It'll be used in these chemical labs. So we're not suggesting that we're targeting the water testing labs or environmental water testing labs. Of course, there's a market there, but we're really going after that chemical industrial market. That's what we want to be known for. So not only are we manufacturing the most accurate instrument and robust instrument out there, but we're also providing all the liquid reference standards that go with it, and also the quality cells that we manufacture here in the UK as a complete solution and package to the user. Hopefully that answers the question. The other players out there are, as you'd expect, we've got Hack, we've got Mettler Toledo, we've even got Japanese manufacturers, Tanaka, we've got Hunter Lab, other companies doing platinum cobalt, but as we mentioned, they're not publishing their accuracy, repeatability values as we are. So there's a definite unique advantage for us to go to the customer with on our product. The next question here is, will any variants of the PFXi be discontinued to encourage customers to transition to these new instruments, Matt?
No, not at this moment in time. We have plans, obviously. you're intelligent people. You can see that we've got a new platform here. It's a spectrophotometer, not a. It's new technology, and you know we are very successful in petrochemical, edible oil, and other markets, and new markets like pharmaceutical. We want to go for. So, but you need different scales, and the voice of customer differs from some of those markets. So, the devil's often in the detail with this sort of thing. So, we definitely will be. You'll be seeing. I'm not talking next week, but in the near future, over the next few years, you'll be seeing more product from us based on this sort of ICX platform, using various benefits out for that software as well, potentially.
Yeah, and I guess a related question there, final question we've got is, will there be the option to upgrade color scales on the Lovibond ICX in the future?
Not at this moment. It will come out with the scales that are currently available. However, we're conscious that's been a real strength of the PFXi, with that scale flexibility, that upgrading, and it's certainly something we'll look at in the future in terms of new platforms, new instrumentation. So we want to build on our huge success with the PFXi, and we know what our customers want, what they like, and we're listening, and we'll bring that forward. So yeah, not at the moment, certainly something we're considering going forward, and there are no plans to discontinue the PFXi at the moment. Rest assured, you'll be some of the first people to know if we do that. And even if we did tomorrow, we'd still support the unit for another 7 years. So just don't be concerned about anything like that. Nothing is going to suddenly become obsolete.
Yeah. Okay. We've got another final question here that I've just published, which is, what options do we have for customers that need to maintain service calibration records beyond just internal verifications with glass or liquid reference standards?
There'll be option upgrades. I'm just trying to understand what options do we have for customers who need to maintain. Well, I'd recommend they get a service contract.
Yeah.
Simple.
Yeah, I mean, we're
Get
forward,
get the instrument serviced and recertified.
Yeah, I mean,
and
certain
issued with the correct paperwork.
Yeah, for certain pharmaceuticals, like industries such as pharmaceuticals, require IQ, OQ, PQ validation. You know, as we develop this base platform, as Matt alluded to, we will be taken into those markets where they need, you know, CGMP, GMP compliance with, you know, very strict protocols on traceability of calibration and servicing. But certainly, you know, the starting point is for them to have a service contract with our approved service channel.
Exactly, which is you guys generating revenue. It shocks me the number of people who do not regularly service their instrumentation and then are surprised when it's not been serviced for 3 years, that it's not functioning correctly. That's why, you know, reference materials are a good way for a customer to check their instrument internally is functioning correctly. And that's why a minimum we provide the conformance filter. But they are not, you know, they should not replace annual service and maintenance of the equipment.
Okay,
there's a cost involved, but for you, it generates revenue for dealers, but also ensure it's more expensive if the instrument goes down and they can't test any of the material for a period of time.
Good. All right, so I think we've come to the end for our time. Definitely overshot a little bit, but it's good to see those questions coming in. We will be sharing this recording, so for any of your colleagues that didn't get the information today, there'll be a link that will be going out for you to download and review what we've spoke about today. And of course, as I mentioned, you'll be able to pick up all of the sales tools, marketing tools from the partner portal. And a final reminder that if you have a customer database, please share that Select Science seminar, which is happening on the 13th with your database, and hopefully we can generate some interest for that and get some early leads and notify the end users out there. So finally, thank you very much for representing Lovibond. We hope to speak to you all soon. And yeah, thanks for attending.
Your hard work is appreciated. Take care. Have a great day or great evening, whatever timeline, wherever you are.
Cheers. Bye.
Bye-bye.